Hello, guys. Good day, and I hope we are all doing good. We are doing another tutorial today on object oriented programming. We started with the concepts, right? So, we talked about the four concepts, and then we started treating them by using code to explain. So, we've talked about inheritance, we've looked at polymorphism. Now we are left with abstraction and encapsulation. So in today's session, we are going to be treating as abstraction, right? We are going to be treating abstraction. So first of all, let's jump into what abstraction means. So what does it mean by abstraction when it comes to programming and when it comes to object-oriented programming? So it is a process of hiding implementation details and only showing the functionality to the user. So, in other words, what the 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 particular object-oriented program is supposed to do is not shown to the user, but what the user needs is what is shown to the user. An example could be comparing it with a website that allows you to log into your account. Let's say KNUST AMAP that allows you to log into your account as a student. Okay, so you have to input your username and your password. When you input that, what do you think happens behind? So something happens, some sort of authentications go on behind, some sort of data is compared with what is in the database. That's the data you supply to the form is compared with your data in the database, and if it is right, they navigate you or they redirect you to another page, and all these are done at the back, right? And these implementations are not shown to you. What you only need is what the interface where you are going to interact with the form, and that is all abstraction is about, right? Another example could be like your DVD player, right? You put in your CD, you play on you click on play, and then everything starts playing. But do you even imagine or have you cared about what is inside the DVD player that makes the process work? Right, so there are a lot of components, there are a lot of semiconductors just inside, just to make sure that your DVD is working, right? And all those components are hidden from you. They are hidden, the implementations are hidden from you, and that is what abstraction is all about. So now let's look at abstraction when it comes to object-oriented programming. What does it mean in the case of object-oriented programming? So let's get into writing some code to explain this. So first of all, let me create a class. I'll call it abstract, right? I'll call it okay. Let me call it doc. So I'll call this class doc. So within this particular doc class, this is a normal class, right? It's a normal class, and in explaining abstraction, we are going to be using what we call abstract class, an abstract class. So let me just comment it out here. So we are going to use an abstract class. So what is an abstract class? It's simply a class with abstract added to the beginning of the class. So an example would be abstract class goat, and this is what we mean by an abstract class. So what does an abstract class do? So in our definition, we said it hides implementation details and shows what the user needs, right? Okay, but let me just give you a little bit of information when it comes to abstract classes in Java. In Java, you can write abstract methods in abstract classes, And you can also write methods that are implemented within the abstract class. Okay, so let's look at that. Let's look at an example of that. So we have we know how to write methods, right? So we can say just public void. Let's say we are going to be printing out let's say uh, sound. So we want to know the sound of a goat, right? So when we do this, we are going to put out some um, implementation here that will make a sound of a goat. Let's say meh. Let me just put something there, something like this, right? So when we have this, we've just implemented this function, right? We've implemented this function. And another thing that abstract classes take is abstract methods. So instead of, let's say, we implementing everything, we can just give it a method, let's say public, then we'll add the abstract keyword, and then we'll give it a name. Let's say we'll give it a name of let's say go, right? When we do this, we've just created a method that can be overwritten. If you remember inheritance, that is how we are using inheritance here. We are using inheritance in relation to abstraction, right? So a particular class will be inheriting from this particular abstract class, right? You get to understand why we need to inherit from an abstract class. We can't create objects out of an abstract class. That is one main point that you should take note of in this particular tutorial. Objects cannot be created out of an abstract class. Maybe you may not understand, but when we start writing the code more, you get to better understand what I mean. So now we've just created an abstract class. I'm going to create another class, and this will be just a normal class. So class animal, class animal, then okay, probably I should rather make the first one animal, so that a goat is part of an animal. So animal first, then let's say goat, class goat. So this class goat is supposed to what? Inherit from the animal class. So we add the keyword extend. If you remember our previous tutorials when we were looking at inheritance, we use this keyword extends to inherit from a particular parent class. So extends animal, right? So we've just inherited okay, let me see. Okay, so anytime you extend an abstract class, make sure that you override all the methods within the abstract class. So you can see that this particular class goat extends animal has been underlined, and if you hover over it, it says that class goat must either be declared abstract or implement abstract method go in animal. So what it means is, if you have abstract methods within the abstract class, you must first implement it before this particular goat class can be run, or we can create objects out of them. So let's say we have a public void go. That is what we have, right? And we are overriding that. And what we want to put there is, let's say, a print out statement. So we want to say go, like something like that. Pardon me, I'm just using some simple words here. Just the main idea here is for you to understand what abstraction is all about. So we've just overridden this particular method. But take note, this was already implemented within the abstract class. Okay, it was implemented, so we don't need to override that here, unless maybe you would want to change the content, and that is where um, inheritance also prevails. If you remember the inheritance video, you can just inherit methods and then change the behavior of those methods, right? So that is it. Now let's come to our doc class, and we want to run this code, so we will include a main. Okay, and earlier on I told you we cannot create objects out of abstract classes. So if, let's say, we wanted to create an object out of this animal class, let's see what will be the error. There will be an error. So animal, let's say obj equals new animal. This is how we create objects, and you could see that there is an underlining here. Let's see what it says. Animal is abstract and cannot be instantiated. You see, so abstract object cannot be instantiated. So that is why we needed to inherit it, and that is why we had the goat inheriting from what, that particular this thing. So we have goats, we have goats. So we've just created an object out of a normal class, right, that is inheriting from an abstract class. Abstract classes will have methods that are abstract or that are either implemented. What it simply means is this goat object is serving as an interface, or let's say what the user will be interacting with, but the abstract class keeps all the things that we all the code that we need to use in the backend. It keeps it safe, or it keeps it from the user. It shows only the relevant things, and the most important things or the implementations are hidden from the user. That is the main idea here. So if we run, if we are supposed to, let's say, run the methods on this object, let's say we want to run the go, then we also probably want to run the sound on this method. Let's see what will be printed out as our output. Okay, so it's now loading. Let's see, let's wait for it to load up, and then we'll get to see the output. Okay, so yeah, that is the output. The go method, if you remember carefully, was an abstract method within the abstract class. So abstract method should be within an abstract class with the keyword abstract, right? And then when it is so, then you have to override that abstract class. Any class that will inherit from that abstract class needs to override that particular method, right? So we overrode that method here. Then when you come to the first method that we didn't really do anything about, it was already implemented. So that is one feature of abstract classes in Java. They can implement methods, or they can give you abstract methods for you to implement in other classes. Okay, so that is abstraction, right? One thing I would like to add with this abstraction is what we call interfaces. So let me just bring a comment here at the top, and then I write the word interface. Okay, so interface is another thing that looks like a class, but it's not a class. What an interface does is that it is going to house, or it is going to contain abstract methods, right? Abstract methods that can be implemented by other classes. And that is how abstraction is also achieved with interfaces. But one difference between an interface and an abstract class is that an interface only contains abstract methods and can never implement a method. It cannot implement, it can only contain abstract methods, so it cannot implement. But let's see how an interface works. So to create an interface, you just simply write interface, the keyword interface. Okay, Then let's say we have the name animal interface. So simply it just looks like a class, but we are not using the keyword in class, we are using the keyword interface. Now we want to create some methods here. So the methods we would want to create are, let's say, void back, then void poop. Okay, so these are just some normal names I picked from somewhere. I'm just using them to explain for you to understand what abstraction is all about. So in this case, you cannot create, let's say, another method and say public void, let's say public void, let's say jump, and then we start implementing that method by saying s out hello, I jumped. So we've just implemented this, but you could see that there is an underline here. It says that interface abstract methods cannot have a body. So abstract methods within an interface cannot have a body. But when it comes to an abstract class, it can, like the case here. You could see that it is having a body. But it can also have an abstract class, an abstract method. But in this case, we use the keyword abstract because we want to differentiate this from this. Because we can implement methods within abstract classes, we want to differentiate the implemented method from a normal abstract method by using the abstract keyword. Then for this case, because we are assuming all the methods that will be provided will be abstract, we don't have to include any keyword there, and we can't implement a method there. Okay, so that is one thing that you should take note of. Now I'll be creating let's say another class. I'll call it wolf. That will be inheriting from this particular interface. So let's say we know earlier that if we want to inherit, we use the keyword extends, then animal interface. Okay. But you could see that there is an error here. There is an underlining here. Okay, we don't extend interfaces, but rather we implement, because we, from the idea, we know that they contain abstract classes. Abstract classes are not implemented, so we use the keyword implement rather than extends, because we are going to be implementing those methods that are in the uh, the interface, right? So there is still an underlining here which tells us that we need to implement the classes that are the methods that are inside the animal interface. So first we need to implement them before um, they can be. So one way to implement is just right clicking and then going to generate. When you go to generate, you can look at implement methods, right? So you implement, these are the two methods that need to be implemented, and they are the ones that have been inherited, right? Great. So I can just print something out from here. Ooh, maybe this is how a wolf sounds. Just something for you to understand. Then we have, let's say, poop. I don't know what this poop should do, but let's say it says hello, I am a wolf. Okay, so that is it. So you could see that we've implemented these methods inside the wolf class, and we use the keyword implements to inherit these particular methods before we before we implement them. Do you get the idea? So that is about abstraction. We can use interfaces to show abstraction. We can use abstract classes to also show abstraction, right? We can print this out for you to see what the output should be. So let's say we create an object, so wolf obj1 new wolf. So we've created an object out of the wolf class. Then we are going to call the methods on that, so back, and then we are also going to call poop. Okay, so let's see what happens if we do that. Now let's print something out. Okay, so you could see that it works fine, right? The first case we are using an abstract class. The second one we are using an interface. The difference is that in the first case we had a method that was implemented, which is the one printing this meh here. And then we also had an abstract class that we implemented with our with our let's say with our with our dog, I think. With our dog, is it dog? We implemented one with the animal method, okay, with the goat, rather, the goat class. So that was this place, this particular place. We implemented this because it was an abstract method from the abstract class. And when it came to the interface, we use an interface. We said that an interface will only have abstract methods which needs to be which needs to be overridden, or they need to be implemented. So that was what we did here. So all the methods within this particular interface were just giving us like um, in other words, when you see this, it's simply telling you that the interface gives you what you need to see. It just needs to let you know that you have a particular method called back. But how the method is implemented is none of your business, right? And that is all abstraction is about. That is what abstraction is about. So we implemented them here, right? But this is what we are going to show to the user. And we the user shouldn't care about the implementation details. The same applies to what? The method, the abstract class with some abstract methods and then an implemented method. So for abstract methods, it gives us some flexibility. It either allows us to implement it ourselves, or it implements the method for us, right? So that is the idea here. That is all about abstraction. And um, thank you for staying. Let me just end this with the thank you. Okay, so thank you. And in the next tutorial, we'll be looking at I think it should be encapsulation. So we'll be looking at encapsulation. So please do well to subscribe to the channel and like our videos. If there is any comment that you would like to make, please, we are open to any comment. We are open to corrections. So kindly do so if you feel like you are happy or you are not happy about something. Okay, so thank you for watching this video, and in the next tutorial we'll be talking about encapsulation. So bye, have a great day.